The next topic, that is sign convention for reflection using spherical mirrors. Okay, so the first topic which you're going to study today is sign convention for reflection, which is using the spherical mirrors. So here the spherical mirror, you can see over here, this itself is a spherical mirror. It can be anything, it can be either convex or concave. In this case I have taken a concave mirror, so just as an example for you all to understand the sign convention. So in this concave mirror, the concave mirror, and I assume this principal axis, you all have studied about the principal axis of any mirror, correct? No? So in this particular thing is the principal axis, that I'll assume it to be an x-axis. You all have studied about the Cartesian coordinate geometry, that is coordinate geometry in mathematics. So same way, this Cartesian coordinate, the horizontal line, that is the x-axis, will be nothing but the principal axis of the mirror, and the mirror itself is going to be the y-axis. And you can see in the x-axis, the distance always towards the left hand side is considered as negative. The distance, it can be anything. For example, the distance, anything if I am measuring, will be always measured with respect to the pole. Pole is the centermost point of the mirror. In that, whatever the distance I am finding out towards the left side is considered to be negative, and the distance found out towards the right side, that is considered to be positive. Okay, I'll give an example. Imagine this person AB, whose head is at A and legs at B. I have to measure his distance from the pole. Okay, he is standing towards the left side of the mirror. So which means I will take a tape and measure from here to here, and that distance, whatever I am finding out, will be the object distance from the pole. It is the object distance from the pole, which means this distance is nothing but my object distance. Okay, and you all can see I have measured it towards the left side because the person was standing the left side of the mirror, which means that distance should be considered as negative. Okay, so now this person is standing straight towards this left side of the mirror, which means this is the ground and he's standing over here. So his height, suppose if I say the reflection takes place in some or this way and all that, the light ray will fall like this and his image is formed over here. So this image will be inverted image, which is a real image, inverted image or a real image, and that distance is found below the x-axis, which means below the x-axis the distance according to the sign convention is considered to be negative. So remember, above the x-axis, whatever the height I am measuring is going to be positive. Below the x-axis, whatever height I am going to be measuring is considered to be negative. Okay, so positive is above the x-axis, negative is below the x-axis, and distance towards the left side, whatever I am measuring, horizontal distance, is considered to be as negative, or the right side, whatever distance, is considered to be as positive. You all have studied about the number line. Left side, this, if you consider this point as the 0 point, this point as the 0 point, whatever the numbers, this side is considered to be as minus or negative, and towards the right side it is considered to be as positive. Okay, so these are the things which I have explained you all right now. All the horizontal distances are measured from the pole. Object distance from the pole is u. Okay, so this distance, whatever, if the person is standing towards the left side of the mirror, and that distance is nothing but the object distance, and it is denoted as u. And the image distance from the pole is v. So suppose if I tell this distance, I'll mark it like this. Okay, like this, from pole to this image. This is the image. This is the image formed of that person, and this is the object. Okay, please understand clearly, this is object and this is the image of that object, and the object distance is considered to be as v. Okay, from the pole. The measurement is always done in terms of pole, and that this object distance is u and the image distance is v. Then f is the principal focus of the mirror, which you have already studied about. The small letter f is nothing but the principal focus of the mirror. Then based on these notations, we have created a formula called as mirror formula, which means it is 1 by V plus 1 by U is equal to 1 by F. Just remember the formula, we need not know the derivation for this formula. So it is, the mirror formula will be 1 by V plus 1 by U is equal to 1 by F. So remember this formula, and this is the topic which you need to understand for the sign conventions in reflection using spherical mirrors. The next topic under that will be magnification. The magnification, the word itself indicates that how changes, what are the changes happening in the image of an object based on the size. Either it can be bigger in size or smaller in size. That is what it defines the magnification of the image formed of an object. So that is nothing but the ratio of the height of the image to the height of the object. So here height of the image, let me assume it to be as h dash, which is considered by your textbook itself. So we can consider the same way. And the height of the object, let it be just h. Okay, h and h dash. So symbolically I can write it as small letter m indicates magnification is equal to h dash by h. That is ratio of the height of image to the height of the object. Or I have another formula which deals with the distance. Previously it dealt with the height. Right now we can deal with the distance as well, which means magnification is equal to the minus of the image distance to the object distance from the pole, that is minus V by U. So this is nothing but my image distance, and this is nothing but my object distance. Okay, so the ratio of the negative ratio of the image distance to the object distance is also magnification. So there are two formulas which will be dealing with magnification. One is h dash by h and it is minus V by U. So now under this you need to make a note of few things under the magnification. First one is the height of the object is taken as a positive. Okay, height of the object, as you can see, the object in this diagram, object is nothing but always standing above the ground, that is to the positive direction of the y-axis, that is in this way, which means this is the distance which is considered to be positive. Nobody is going to stand inverted to the ground, correct? So object is usually considered to be as positive. The height of the object is taken as positive as it is always standing above the ground, standing in a straight manner. So height of the virtual image is taken as negative. So imagine you all have learnt about the virtual image formation using convex mirror in the previous video. In that previous video you have seen that the image, actually somewhere the lines would be diverged and the image would be formed here, correct, no? So image is formed here, and this type of an image formed was virtual image. Why? Because it was straight or erect. Okay, so such type of image is called as virtual image, which is formed behind the mirror and is usually erect and straight. The virtual images are erect and straight, so which is taken as positive. As you know, why it is positive? Because it is measured above the x-axis or towards the positive direction of y-axis. I hope this is clear. The next topic, the next note you need to know is about height of the real image is taken as negative. As clear as this, you can see the real image is usually inverted, correct or not? So the real image formed is below the x-axis or in the negative direction of the y-axis. So here is the image and this is my real image. Agree? So this is my real image. So that real image of this particular object is considered to be as negative. Why? Because it is inverted. So these three notes, height of the object is taken as positive, height of the virtual image is taken as positive, and height of the real image is taken as negative. And if the magnification is negative, then the image is real. Okay, if the magnification is negative, then the image is real. If the magnification is positive, then the image is virtual. These two will come across when you are coming across the problems. Okay.